Okay guys, so we are going to go through the 212 notes. So you guys should have your notebooks out and you guys should be writing down, obviously, the title, Angles Formed by Transversals. So I would like you guys to pause this and read number 213 and then go ahead and write down the answers. When you unpause it, I'm going to be going over the answers for that problem. So in 213, it asked you guys to list if these angles have the same measure or are equal measures, are complementary to each other, or are supplementary to each other. So if you take a look at the first two angles, we call those supplementary angles. In other words, they add up to 180 degrees. They're your windshield wiper angles. In B, you can see that these angles are vertical angles, and therefore, because they are vertical, will always have the same measure. In C, you can see these two angles right here are complementary, and therefore they are going to add up to 180 degrees. And in D, we have an isosceles triangle, and therefore they are going to have equal measure. Okay? So again, you can see that in B and D, those have equal measures. Okay, so again, you guys are going to pause the video. You guys are going to read 2 and 4. You guys can try 2 and 4 on your own, and then you can unpause it and we'll go through it. So in 2 and 4, Marco was walking home thinking about special angles. He saw a lot of special relationships in the pattern, so he decided to copy this pattern in his notebook. In his pattern at the right, I have a resource page and I will give it to you guys when I get back. This type of pattern is called a tiling. In this tiling, a parallelogram is copied and translated, which means slid, to fill an entire page without gaps. View this interactive tool if you want to. Since each parallelogram is translation of another, what can be stated about the angles in his tiling? Okay, consider the angles inside a single parallelogram. Which angles must have equal measure? How can you justify your claim? And then C, what about the relationship between the lines? Can you identify any lines that must be parallel? Mark those lines with the arrows. So if you take a look at this, if I were to color this pink, this blue, this orange, and this green, and we were to actually cut this parallelogram out and slide it down, what happens is this becomes pink, this becomes blue, this becomes green, and this becomes orange. And so when you end up doing this, you start to see the pattern. Now, once I move over, so let me do this one, pink, blue, orange, and green. Once you start to do this, and then again, copy, can I not paste it? Here we go. Pink. Oh my goodness. Blue, orange, and green, right? So we're coloring each of the angles. And I am going to draw you into looking at the vertical angles because yesterday we learned about vertical angles. And so vertical angles, for example, this one and this one, are always congruent to each other. So after knowing vertical angles are always congruent to each other, it's like, wait a minute, if this angle right here is pink, then this angle right here has to be pink. And if this angle is blue, then this angle has to be blue. So then you start to think about, wait a minute, how is this tiling supposed to actually look? Okay, so I'm going to start again, this angle is pink, and I'm just going to do the pink angles first so you guys can see. So we have these pink angles, and what we have is the vertical angle. So this angle right here has to be pink because it's vertical. And if that's pink, then you have to put all the other pink angles in. So you start to see which angles in a parallelogram are equal. The same thing goes for the other diagonal blue angles. You have this pattern of this tiling. And so you can see that in a parallelogram, you have a bunch of equal angles. Okay, so let's go over here and let's answer our question. Okay, color all the angles that must be of equal color. Check. Consider the angles. Which angles must have equal measure? I'm going to say the opposite angles. How can you justify your claim? And we did it above using vertical angles. So in my picture and in my notes, in my notebook, I'm going to make sure I have a parallelogram drawn. And I'm going to make sure I know that those angles are equal and these angles are equal by putting these tick marks on there. And then, of course, because it's a parallelogram, the opposite sides have to be parallel. That's my symbol. So if you guys remember, you use those fish gills. Okay, so again, in my notes, I would make sure I have a parallelogram drawn, and I would make sure I have the fish gills and the opposite angles marking as equal. Okay, so you guys are going to pause again. You're going to read 215, and you guys are going to answer these questions. So Julia wants to learn more about the angles in Marco's drawing, and just focused in on one part of his tiling. An enlarged view of that section is shown at the right, with some points and angles labeled. A line that crosses two or more lines is called a transversal. So we're going to go ahead and we're going to put that in our notes. In Julia's diagram, which line is the transversal? And so I am going to highlight the transversal in orange. Okay, so we are going to call that line JK. And we're going to put a line over the top. And then it says which lines are parallel. And you can see that using the arrows. And so we are going to label the parallel lines as line LM and NP. Trace angle X onto tracing paper and shade its interior angle. Then translate X by sliding the paper up the transversal. Which angle matches exactly in the diagram with angle X? And you guys can see that in this diagram, you have angle X, and it asks to go ahead and shade it in. And I am going to cut it and slide it. It's fine. Okay, and you guys can see that if you slide it up the transversal, it lands on angle B. Okay, so angle X fits in exactly with angle B. Angle B. I'm going to continue on down here. Nope, guess not. In this diagram, angle X and angle B are called corresponding angles because they are in the same position at two different intersections of the transversal. What's the relationship between the measure of angle X and angle B? So those angles are equal. Okay, again, corresponding angles in your notes, and I would probably draw that picture as well, like this, and I would put angle X here and angle B here, and I would say same location in a different intersection. So again, you guys are in driver's ed. I have my pink intersection, I have my blue intersection. You can see they're both standing in the northeast corner of that intersection. Okay, again, you guys are going to pause this. You guys are going to read 216. So the corresponding angles in Julia's diagram in 215 have equal measure because they were formed by translating a parallelogram. Name all the other parts of corresponding angles you can find in her diagram. So we're going to come back up here. And we're going to list all of the corresponding angles. Okay, so again, we have angle X with angle B. We already stated those are corresponding. We have angle A, which is corresponding with angle W. Angle C is corresponding with angle Y. And angle D is corresponding with angle Z. So to fill that out, we're going to have angle A corresponding with angle W, angle C corresponding with angle Y, and angle D corresponding with angle Z from that diagram above. I'm going to drag this down to answer my question. Now suppose angle B is 60 degrees. What would you know about vertical, supplementary, and corresponding angle relationships to find the measure of the other angles? So if angle B is 60 degrees, and I come back up here and I fill that in, I automatically know that angle X would have to be 60 degrees. And then again, because we have vertical angles, I'm looking at angle C, that's vertical, it'd have to be 60, and angle Y is vertical, so that would have to be 60. And then I see some windshield wiper angles. So angle A is 120. If A is 120, it's corresponding with W. So W is 120. And then D is vertical. So that's 120. And Z is vertical. So that's 120. And again, you guys can pause this and play it back if you need to. But those should be all of your angle measures. So Frank Weather's weather corresponding angles will always have an equal measure. For parts A through D, use tracing paper to figure out. Then determine if you have enough information to find the measure of X and Y. So if I was to use tracing paper and I tell you that this angle right here is 135 degrees, and I take it and I slide it over, does that look like it's also 135? Absolutely. And then because I know that that is, oh my goodness, I don't know what just happened. Because I know that X is 135 degrees and it is vertical with Y, I know Y would also have to be 135 degrees. So X is corresponding with 135 degrees, and then Y is vertical, so it is also 135 degrees. For B, if I trace this, again, 135 degrees, and I slide it over, that does not fit. Okay, so I don't know how big X is, which is weird. I don't know, guys, I'm getting really annoyed. It's really weird because X is corresponding, but it's not equal to 135 degrees. Obviously, it's smaller. It looks smaller. And then the Y, you can see the Y is supplementary with 135 degrees. So that means my Y is equal to 180 minus 135, or 45 degrees. Right here, so again, I have my 135 degree angle. I can take it and slide it down, and it does work. So my X is corresponding and is equal to 135 degrees. And then if I continue that, you can see that Y is supplementary to 135. So Y is equal to 180 minus 135, which is 45 degrees. And the last one, D, this one's definitely not going to fit either. So there's my 135 degree angle, and yeah, that's not fitting. So I don't know how big Y is. Y equals question mark. But my X, I can easily do my windshield wiper angle back and forth attached, right? Here's my windshield wiper and it flicks back and forth. And so my X is supplementary to 135 degrees. So X is 180 minus 135, which we stated as 45 degrees. Okay, So do corresponding angles always have equal measure? My answer is going to be no. If not, when are they equal? So looking at just the corresponding angles, you can see that in A, it did work. In B, it did not work. In C, it did work. And in D, it did not work. And so the difference between these, if you just glance at these, are A and C, which did work, and that is because of the parallel lines. So that's really important when looking at corresponding angles. So when are corresponding angles equal? When they are on parallel lines. So write an if-then statement called a conditional statement. So in my notes, I would make sure I knew a if-then statement. It's called a conditional statement. Make a conjecture about corresponding angles by completing this. If blank, then corresponding angles have equal measure. I would say if lines are parallel, then corresponding angles have equal measure. Only when the lines are parallel. Okay? And then for 218, for each diagram below, find the value of x if possible. So I'm looking, and we're going to take our 115 degrees, and I'm going to slide it over here. Okay, so that one has to be 115 degrees. And again, you can see the parallel marks. You can see that, oh my God, I swear this is the last problem. So you can see that this is parallel with this. So when I slid this over, it matched up right there. Okay. You can also see that this blue line is parallel with that blue line. So when I slide this up, it matches. Okay, so this is obviously 115 degrees. I don't know why it's doing this, so 115 degrees, and therefore this is 115 degrees, and therefore x has to be 180 minus 115, or 65 degrees. To find x, for B, it looks like I only have this set of parallel lines, so I can take this 53 and move it, touching the parallel lines. I cannot go down here. It's not going to fit. You can see it doesn't fit. It does fit here. So this is 53. But it does not fit there. So I don't know how big x is. We're going to say x is question mark. And then for C right here, oh, this is our parallelogram tiling problem. So if this is blue, and I slide it over, and I slide it here, you guys can see then that because of vertical angles, this is blue. So if you remember with the tiling, all of these angles right here, because it's a parallelogram, all these angles have equal measure. So in other words, 4x minus 25 is equal to 3x plus 10. I don't know why I put 35 plus 10. X plus 10. And then you guys would go through and solve this equation. Minus 3x minus 3x. I'm left with 1x minus 25 equals, drop it down, 10 plus 25 plus 25. X is 35. Okay? And then if they wanted you to find the measure, you would plug 35 back in and figure out how big that measure is.